Precalculus problems from section 3.4. In this first group of problems, some of them can be done without a calculator, and there's a couple that need calculator. I'm going to do the ones that can be done without a calculator, and just keep in mind that when we have quizzes or tests and there are calculator parts of that, you'll only be able to use your calculator for the calculator parts. So in other words, I think the ones that I'm doing without a calculator, you should know how to do them that way. So, I mean, this is just a stare-down problem, right? What do you have to raise 4 to get 16? There isn't really any work to do unless you want to think about it as writing out. You could maybe say, oh, I'm going to rewrite that as a logarithm. That's log base 4 of 16 equals x. And then you're like, okay, log base 4 of 16, what do I have to raise 4 to get 16? But it just boils down to that same thing. I think that this is a more intuitive way that we think about these things, more intuitive than logarithms. For my math brain, and probably for yours too, you're a little bit more comfortable with this than you are with this. So when you see a logarithm, you're more likely to think about this in this way to unlock what that x should be. So, same thing, I think, in 25. It's not a bad idea, got to know your basic powers. That 625 is a power of 5. It's 5 to the 4th power. Now this got flipped over, so that means that 5 got raised to the negative 4 power. The negative sign flips it over. Well, if you squared, if I raised 1/8 to the 2nd power here, that would be 1 over 64, but that's flipped over, so x must be negative 2. Right? It's flipped 8 back up to the top and then squared to get 64. Similar problem. Oops, sorry, that's supposed to be 16. I had 64 on the brain. Okay, so 3 raised to the 4th power is 81, and 2 raised to the 4th power is 16. So it looks like x here is negative 4. The negative sign is flipping this over, and the 4th power part is raising them to the 4th powers. Number 31. Okay, this is a calculator job here because I don't know. E is like a 2.7 yada yada yada, ugly looking number. I don't know what to raise that to get 14. It's going to be some kind of decimal. So how do I do that? Not by guessing and checking. That would be a bad plan. I'm going to take the natural log of both sides. This is a step that you might skip once you get comfortable with doing this kind of problem where we're going to take the natural log of both sides. And then natural log of e to the x. The reason we did that is this just turns into x, because what do you have to raise e to get e to the x? Just x. And then, so the solution to this is just the natural log of 14. And I think that we want our answers rounded correctly to 3 decimal places. So I'll just have the calculator do that for me because, well, why not? 2.639. All right. Next one also looks like not calculator. Oops, 10 to the x is in there, equals 216. Here's the tragic algebra mistake, to distribute the 6 in here and be like, oh, that's 60 to the x. Wrong. You cannot. Exponents are higher up in the order of operations, so that cannot distribute into that. That means I have to divide by the 6. So instead of doing distributing it here, I'm just going to divide it over to the other side. 216 divided by 6, I think that's 36. And then 10 to the whatever, just like the e to the, this is, I'm going to do the common log of both sides of this, because log base 10 of 10 to the x, that just turns that into an x. And that's log 36, 1.556. And I did say, I did want you to check answers when you're doing these calculator problems. How would you do that? To check your answer, you just go back to, okay, if I'm raising e to the, I'm claiming that 2.639 is the answer, 2.639, and just see, like, am I getting 14? Yes. And then, like in this one right here, I'm claiming that 6 times 10 to the x is equal to 216. 6 times 10 to the, my x is 1.556. So that gives me about 216. If you're wondering why it's not exactly 216, it's, well, we rounded that. So that's why. All right. Number 35. This I can do without a calculator, because 256 is a power of 2. You could kind of count up 2, 4, 8, 16, 32, 64, 128, 256. So 256 is 2 to the 8th power. So this must be 8. So x must be 5. Sorry, that should not be there. All right, solving logarithmic equations now, a little bit different. First one looks like this. So one of the properties of logarithms, one of the very basic ones from section, I guess, 3.2 maybe, is if you have log of something equals log of something, and it's the same base logarithm, then those two things just have to be equal. Kind of obvious, right? 39, natural log of x is equal to -9. Well, natural log is log base e, right? So that's the rewrite of this. Sometimes it really does help to just rewrite natural log as log base e. That means e to the -9 is equal to x. And, I mean, you could do that with your calculator, but that's the exact answer, so whatever that is, I think we're happier with that version of the answer, right? Number 41. Log base x of 625 is equal to 4. Well, that's the same as saying x to the 4 equals 625. So you could, with your calculator, take the 4th root of that, but maybe you remember, we've seen already, this is a power that probably you should know, that 5 to the 4th power is 625. Fact. What was that? That was 41. Number 43. Log base 10 of x is equal to -1. what do you have to raise 10 to get negative 1? What power do you have to raise 10? Oh, no, sorry. So sorry, rewrite of this in exponential form. This means that 10 to the negative 1 is x. So, sorry, I was saying it the wrong way. So that's just the rewrite of this in exponential form. So x is 10 to the negative 1, which is 0.1. That means 1 over 10. Sorry about the momentary confusion. Natural log of 2x minus 1 is equal to 5 here. I'm going to do the same thing. So natural log is log base e. So this means that 2x minus 1 is equal to e to the 5th. And then whether you turn this into a decimal now or not, I don't know. I always like exact answers if I can get them. So I'm just going to do the algebra on this, add 1 to both sides. So e to the 5th plus 1 over 2. Sure. Oh, wait, hold on. I'm not doing 47. Just kidding. We're jumping to 55 now. Let's see what we got there. Solving an exponential equation. So solving exponential equations, this is going to be a lot of calculator work, and the first move is going to be to try to get the x out of the exponent. We need to take the logarithm of both sides. Now, because of the whole change of base thing, excuse me, you could use natural log or you could use common log. It doesn't matter. I'm a big fan of natural log for calculus reasons because log base e turns out to be the most important one. So that's the one that I'm going to use. But if you want to use, in the end, whether you're doing the problem pushing your log button or your natural log button is not going to matter. You're going to get the same answer. So natural log of e to the 3x, the reason that I'm doing that is because I can bring that exponent down to the front, like that, is equal to, now I took the natural log of both sides. So then, looks like I'm going to divide both sides by 3 natural log 8. I'm trying to get the x by itself. So I'm going to divide these other things off to the other side, like that. And then when I put that in my calculator, I got to be careful. I'm going to use the little fraction feature. Remember, you get into that by doing alpha, getting into the F1 menu. So green alpha key and then y equals. And now I'm just going to enter it just like I have there. Natural log 360 over 3 natural log 8. And I'll check some answers as we go through these. So let's see. So 8 raised to the 3 times. Did you know you could bring up the last answer that you had by doing this second and the subtraction, or the minus sign rather? So I can do second answer, and it puts answer there, which means it's the last number that I put in there. And that's 360. That's what we want. All right. 57, 5 to the negative t over 2 is equal to 0.20. All right. So I could natural log both sides. natural log 5. And then the reason that I do that is because that means the exponent can come out to the front. Negative t over 2 is equal to the natural log of 0.20. So to get the t by itself, let's see. Whether you want to do this in one step or not, it's up to you. It comes down to algebra confidence, I think. So I'm going to go ahead and multiply both sides by negative 2. That's going to get rid of this. So t times natural log 5, multiplying by negative 2, because it was on the bottom here. And then I'm going to divide by natural log 5. And then I'm going to get my calculator. Negative 2 natural log 0.2 over natural log 5 is 2. All right. Let's see where we're at here. 59. These ones are a little slower going. I got 250 e to the 0.02x is equal to 10,000. Okay, so I think the first thing that I would do here would be to divide by 250. 10,000 divided by 250 is at 40, I think. And these are calculator problems. We're allowed to do this, right? And then I'm going to take the natural log of both sides, because that allows that to come to the outside. And this one was an e there, so natural log of e is just 1. And 0.02, that's 2,000, I think. 200? 2,000. Let's just check. 40 divided by 0.02. 2,000. 61. 500 e to the negative x equals 300. Divide by 500 first. 300 over 500 is 3/5, or 0.6 if you want. And then going to natural log both sides, because that means I can bring that to the front. And natural log of e is just 1. That cancels out. So x is equal to multiply both sides by that negative sign. Negative natural log of 3/5. Negative natural log 3/5. 0.511. 63. Is 7 minus 2 e to the x equals 5. So a little bit of two-step algebra kind of action here. So let's see, that means I'm going to subtract this 5 over here, and then I'm going to add this to the other side because I'd just rather not have it be negative, right? Okay with those moves? I hope so. And then we get e to the x is equal to divide both sides by 2. E to the x is equal to 1. I don't need my calculator for that. X has to be 0. If you're going to raise e to something and get 1, that's just 0. Number 65. Five times 2 to the 3 minus x minus 13 is equal to 100. I'm missing some. Oh, sorry, that parenthesis there. That's why that looks weird. There we go. So same kind of deal. Going to do some algebra first. Going to add the 13 over here. That gives me 113, and then I'm going to divide by 5, and then 2 to the 3 minus x. Then I'm going to take the natural log of both sides, natural log 2, because that allows this 3 minus x to come out as an exponent. It needs to be in parentheses. If you don't put the parentheses there, it's wrong. And now I'm trying to solve for x, so I need to divide both sides by this, natural log 2. So that gives me 3 minus x is equal to 113 over 5. If you divide a fraction by a number, it's the same as putting that number in the denominator. That's just like a math fact. Did you know that? Then I'm going to add x to the other side and then subtract this. So that gives me x is equal to 3 minus this. Maybe we'll check our answer on this one. This looks like a fun one. So 3 minus 113 divided by, you know what, I should use set a good example for you. I should use the little fraction thingy here. 113 over 5 natural log 2. How about that for an answer? And apparently that's equal to negative 29.605. Okay, so let's check our answer. That means if I put this expression in with answer right here, I should get 100. That's how I can check my answer. So 5 times 2 raised to the 3 minus answer. That was second minus sign to get the answer there. Close parentheses. Minus 13. Just going to pause for a second, make sure that that looks right. It does, and I should get 100. And I didn't. Oops. This is why we check our answers, right? 5. Okay, so what did I do wrong here? I did 130. Was it check 13? All right, I added that. Divided by 5. Oh, I forgot. Shoot, that was dumb. When I did the natural log of both sides, I didn't do the natural log of this side. So that should be natural log of 113 over 5. So that changes things. So this here would be natural log of 113 over 5 over the natural log of 2. So that kind of changes how I can deal with that. I need to leave it like that. And then this should be 3 minus the natural log of 113 over 5 over natural log 2. And that's not equal to that. So let's go back and get the decimal answer for this. 3 minus... Now, if I were you, if I were a student in this class, I would be making a mental note to myself. I think that that's a mistake. Of all the different things that I could do wrong, I think that that's a likely one for me, is when I take the natural log of both sides, I forget to do it to the right-hand side. Good to try to develop that kind of self-awareness, catch your mistakes. And best way to catch your mistakes, check your answers. So I think that should be our answer now. That's negative 1.498. So let's try again. And I think I can get, since I had, no, it should work. If I go back to do this second entry, this brings back the last things that I had. So now this answer should be this answer, right? So my answer check here putting this thing in that I had already typed in. I just brought that back by doing second entry until it brought me back to there. And then if I hit enter, there we go. Got my 100. 100. All right, what was that? 65. So 67. Good thing I give you so much time to do these problems, huh? Point 1, is that point 1? Yeah. 0.1 over 12. What a weird way to write that. So this is supposed to remind us of one of those compound interest kind of problems, I think. Okay, so how do you do that? Well, first thing you might realize, like, this is just a number, right? So, I mean, whether we want to, like, get a decimal for that now or later, I don't know how you feel about that. But this whole thing is just a number. So really what I need to do is get this out to the front. So I'm going to natural log 1 plus 0.1 over 12. And then that allows me to bring this to the front. I'm not going to forget to do the natural log of this side also. So to get t, I need to divide by 12 and this. So I've got natural log 2 over 12 natural log. I'm dividing everything off of this side except for the t. Natural log 1 plus 0.1 over 12. So I can get that into my calculator just like that. So natural log, definitely want to use my little fraction feature. Natural log 2 over 12 natural log 1, oh, it already gave me parentheses there, 1 plus 0.1 over 12. That should be it. 6.960. That's probably one where we should check our answer, right? So if that's the right answer, then this expression here on this thing here, I'm going to enter that in and see if I can get 2. So I got 1 plus 0.1 over 12 raised to the 12 times, and then I'm going to use that answer feature. Answer. And that should give me 2. Boom. Answer checked. Number 69. Got 5,000 times 1 plus 0.005 to the x all over 0.005 is equal to 250,000. Okay, so there's some algebra here I can do first. I'll go ahead and divide by this first. So dividing that by 5,000 is going to give me what? 50? I think. Okay. And just to make sure I don't make any mistakes, I'm not going to skip any writing any of these steps down. And then that's just a number down here, so we multiply both sides by 0.005. Notice I just hit multiplication. That automatically brought up, the calculator knows that that means I want to multiply the last thing that was there by 0.005. That's 0.25. So 1 plus 0.005 to the x is equal to that. Okay, now I need to get that x down, so I'm going to natural log both sides. 1 point, and sorry, I was going to write this, I am going to write it like that. 1 plus 0.005 is 1.005, right? So I can just do that. And then the reason I did that is because I can bring that x out to the front because of logarithm rules. I'm not going to forget to natural log that side also. So it looks like my x is going to be the natural log of 0.25 divided by the natural log of 1.005. Natural log 0.25 over natural log 1.005. Negative 277.951. If you're like, okay, that seems like a crazy answer. Okay, you want to check this one? Here we go. Got to put this expression here in with answer right there. So I got 5,000 times, I'm going to put a fraction in there. On the top of it is 1.005, because that's what 1 plus 0.005 is, raised to the answer power, and on the bottom 0.005. If we type that all in right and we got the right answer, that should come out to be 250,000. Boom. All right, going to continue at number 71. All right, there's two things going on here. Well, there's one problem here, but there's two ways to solve it. One is to recognize that this is in quadratic form. In other words, it's of the form something squared minus number times that thing minus a constant. Like it's kind of like x squared minus x. It's kind of like this type of problem, but with e to the x's. If you see that, then that's great. Instead of x's at the front, it's e to the x's at the front, because e to the x times e to the x, you add the exponents, it's e to the 2x. And then it just factors, same game. To get the minus 4, you'd have to have like a minus 5 and a plus 1, right? Which means that you have from here, either this would have to be 0, which means e to the x would have to be equal to 5, or e to the x would have to be equal to negative 1. Natural log both sides, x equals natural log 5. This, you can't raise e to something and get a negative number, so that does not give you a solution. So the answer is natural log 5, which, in case you wanted a decimal answer, is 1.609. If you're like, oh, okay, I don't think I'm going to be seeing that, then I'm not like super, it's not super important for me that you do it that way. It is an incredibly useful skill to know how to solve an equation like this by graphing. Two ways to do that. If you have an equation with expressions on both sides, you can graph both sides and then see where they intersect, right? I think we did a little bit of that. And the other way, get everything on one side so it's equal to 0, then graph this and find the zeros, or in other words, where it crosses the x-axis. This is already set up equal to 0, so I think it makes sense to do that second option. So just going to enter this in, e to the 2x minus 4 e to the x minus 5. Now, I don't know where I would be looking for my answers here, and I don't know what the last thing that I graphed was, so I don't know what my window is. The default, where I want to start, I don't just want to hit graph, because who knows what like crazy window I was looking at here. This isn't actually that crazy, but the default, what I want to look at is the standard window. I want to just start with the negative 10 to 10 window. If you want to get back to that one, you could enter it manually, but Z standard, number 6, that's your negative 10 by 10 window. I'm going to do that. Boom. So there's my answer. I already think that by doing it the other way that that's going to be at 1.609. So let's see if I can find that 0. You go second, calculate, 0. Now the calculator is going to ask me for a left boundary and a right boundary. You can play this little cursor game and move it back and forth until you think I'm on the left of it now. Enter, then you're going to have to go to the right. I don't like that game. I like just looking at it and seeing like, okay, being very, very cautious, I can see definitely that the answer is somewhere between like 0 and 3, right? So I'm just going to type in the left bound and the right bound. Left bound, 0, enter. Right bound, 3, enter. And then you have to hit enter one last time, 1.609. If you don't like that whole left bound, right bound thing, the other option is you could treat this like it is two different things, like I'm looking for the intersection of this and this. So you could go back to the y equals and just put in y equals 0 here, right? Like you're graphing both sides, and then graph. And then in the calculate menu, you're going to look for an intersection instead of a 0. Intersect, and then you just go boom, 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 1, 2, 3, 1.619. Maybe you like that better. I don't know. Got to make your own choices in life, right? All right. Number 73. E to the x is equal to e to the x squared minus 2. We got two games to play here too. Same deal. If you recognize, oh, if e to the something equals e to the something, then those two things have to be equal to each other. And let's see, I know how to solve that problem if I subtract the x over to this side. Excuse me. Then factor that. That works. Let's say you didn't see that, and then you're like, can I do it with my calculator? Yeah, it's the same exact thing that we just did. I'm just going to graph both sides of this. I'm going to graph e to the x, and I'm going to graph e to the x squared minus 2. And I'm going to graph them. I'm in my standard window right now, so that's a good place to start. All right, and I'm looking for intersections. Now, these do intersect in two different places. You can kind of see them there, and we already know that it's at -1 and 2. So when I go to my second calculate intersect, the way the calculator does this, like right now it's at 0, at x equals 0, so that's closer to this one. I think if I hit boom, 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 yeah, it's going to give me that one. How do you find the other one? Well, you got to move the cursor over. Second calculate, number 5 for intersect. I got to get closer to that one, so now I'm pretty close to that one, and it'll give me that intersection at 2. But it would be up to you if you did it this way with the graph. Then it would be up to you to spot that there's 2 there. I'm going to show you one more thing, one more calculator trick that you might not be aware of, which is how to draw a zoom box. If you're looking at this graph and looking here and being like, I'd like to zoom in, but like I'd like to be able to control the zooming in process, and I can I'd like to be able to see this part of the window. You can do zoom number 1, option number 1 is a zoom box where you move. It's kind of like doing a screen snip, if you ever do that, like in your physics class or something. Move that cursor to like the bottom corner of where you want to draw your box. Then I'm going to hit enter, and then move over to the side, and then up. So when I hit enter now, it's going to resize the screen. It's just going to zoom in on exactly the part that I drew that around. And then maybe we can see a little bit better in this window the intersections at -1 and 2. So there's options for how to do that. Number 75. This is like exactly the same problem here. So I tell you what I'm going to do here. I'm going to do it my algebra way, what I think is the easy way, if you recognize it. E to the this equals e to the this. So x squared minus 3x has to equal x minus 2. And then if you want to do it the calculator, the graphing way, you can try that your own self. So let's see what we got. Oh, maybe this one doesn't factor. Dang it. So x squared plus x, I'm adding that to this side, and then add the 2. That does not factor. Oh, I think this might not have any real zeros either. So if I recognize that this doesn't factor, be like, okay, I'm going to go quadratic formula on this. So that means x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But the problem is here, this under here, that's negative. So there's no real solutions to this. You can't do it. What is that going? Maybe just real quick, I'll show you what that would have looked like in the graph. Let's see, e to the x minus 2. I'm just going to reuse that because it's pretty close. And then this one was e to the x squared minus 3x. I'm going to go back to my standard window. Before I hit graph, I'm going to do zoom standard. What? What the heck? I'm pausing here trying to figure out what is happening, because I feel like those shouldn't intersect each other because I did it this way. Alright, what the heck's going on here? Learning moment. Let's go ahead and do the Z box here. I mean, those are definitely intersecting right there, right? But the algebra way of doing it is telling me that intersects 1, 2 times. Okay, so did I mess up? Oh, b squared. Wait, no, that's right. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That, I do not see anything wrong here. I'll tell you what, I'm going to, since this video is coming out to be kind of long here, I'm going to figure out what's going on with that, and I'm going to return the first thing that I do in the second video for this section is I'll come back and we'll figure out what exactly is going on with number 75 here. So I'll revisit this and get the last two, and then we'll do the last section of problems. Okay, bye.